If you want to commit anything to memory, then there's really only two basic ideas that you need to know: spaced repetition and active recall. These are the very basics of learning how to learn and how memory works in our brain. And essentially, spaced repetition plus active recall is just repeatedly testing yourself. So in this video, I want to show you guys what spaced repetition and active recall are, and I'm also going to put in a personal study session of mine so that you guys can see how to implement these ideas. But before we get to all of that, I first need to show you guys what the Ebbinghaus forgetting curve is and why it's important. Hermann Ebbinghaus was a German psychologist who found that spacing out a certain practice resulted in better retention. So this is shown with the Ebbinghaus forgetting curve. On the x-axis is time, and on the y-axis is retention, which is just the memory of a thing. In the first curve, we can see that as time passes, we forget the material fairly quickly. If we review the material after we've forgotten it for a bit, the retention spikes back up to the top, but falls as well. If we look at each consecutive review period, the slope of the forgotten material gets shallower and shallower. This shows that the more we review in a spaced interval, the slower it takes to forget the material. So why is this important? Well, we can take advantage of this concept with the use of spaced repetition. Spaced repetition is a way to structure our study sessions over time for the maximum retention by spacing out our studies over multiple days rather than just cramming it in one day, which is what a lot of people do. The key is to time it just right so that in the review session, we have just the right amount of challenge, but not so much that it's too hard to start. A study done in 2003 by Mihaly Csikszentmihalyi, who was a well-renowned focus expert, and the Chernoffs as well, revealed a kind of flow state for students. So this flow state requires high challenge as well as high skill, resulted in the students having higher engagement, more attention, greater interest, concentration, enjoyment, and overall positive mood compared to the low challenge and low skill environments. We can apply this to our spaced repetition by timing and spacing the study sessions in a way so that the challenge matches our skill level. So now that we know how to space out our study sessions, what should we do during each session? This is where active recall comes in. As the name suggests, active recall is recalling your information actively as opposed to passively. An example of this is a flashcard. When you see the term on a flashcard, you are prompted to actively think and recall the definition. A passive example is just sitting down to study and rereading your notes or highlighting the book without recalling or thinking about it at all. There are 3 active recall skills that work well for me. They expose your weaknesses and directly focus on your brain actively working and thinking hard about the answer. Before I get into these, I just want to mention that when you're studying, it will be hard. That's good. If your brain is working hard to get the answer and you do get the answer, then that means you're learning. So don't give up on the first hard question. As mentioned before, you want to find the balance between challenge and ability. The first active recall skill is my favorite. It's called the protege effect. I talked about this in a previous video if you want to check that out, but essentially it's teaching. Popularized by the physics professor Richard Feynman, the protege effect is teaching what you know in a simple and concise way. My process is to sort of jog my memory a little bit by skimming over my notes and then just standing up and acting like a professor who is an expert in that topic. You can look at your notes a couple of times to get yourself back on track, but I try to limit the times that I do that. After you're done teaching, look at your notes and find what you missed. If it's your first time doing it, it will be hard and you'll notice the gaps in your knowledge. That's a good thing because that shows you what you need to work on and review. This also forces you to explain something when you haven't explained it before. Especially in math, there will be some concepts you know you understand, but you can't explain it in words. This forces you to do that, which strengthens your knowledge of that concept. The protege effect can also be used throughout your entire study process. If you're reviewing a certain topic that you're not as proficient in, try to explain it to yourself without looking at any resources. If you got a problem wrong, explain to yourself why you got it wrong and how it should be fixed. The next active recall skill is pretty obvious. It's just to do problems. I mean, this is so helpful in math where there are certain procedures that you need to sort of lock in and ingrain in your mind. In all subjects, though, try to just mess around with like the variables or the terms used in the problem. This makes you think more outside the box and apply what you know to more unfamiliar circumstances. So you can even try creating your own problems and answers and check their validity with your teacher or something like ChatGPT. The key to these problems is to truly try your best at it before looking at the answer. It's a very common temptation to look at the solution after getting a general idea of the answer, but don't do this. It'll be much more beneficial to complete the whole process before seeing if it's right or not. So what do you do when you get a problem wrong? Don't just skim the solution and tell yourself that you understand. Read the solution thoroughly and genuinely understand why you got it wrong, and then go and do a similar problem without making the same mistake. If you get the problem right, don't just forget the whole process and move on. At this point, you can try changing the question to get a different answer, or even create your own questions. The last thing I want to say about practice problems is that you don't need to do a ton of them. It's better to get a problem wrong and completely understand why you got it wrong and do better next time than to mindlessly just do 10 problems when getting them right without any purpose. Okay, so before we get to the last active recall skill, I want to take 10 seconds to tell you that if you like this video, want to see more learning how to learn or self-improvement content, then definitely like the video and subscribe to my channel. The third active recall skill I have for you guys today is blurting. It's pretty similar to teaching, but encourages more connecting of the information. Take out an empty piece of paper and just scribble every single thing that you know about the topic you're learning. The key is to make a mind map instead of just writing a bunch of bullet points. Connecting the information is so much more beneficial than just scribbling. If it's too hard, you can start out with a list of terms in no particular order and connect those terms in a way that you know how. But as you get better at this, try creating your web without a list of terms and just brain vomiting every single thing that you know. To demonstrate all of these techniques, I'm going to take you through a personal study session of mine so that you guys can get a better idea of how to implement these ideas. Chapter 11 in my Algebra 2 book, this is about like series and sequences. So I'm going to implement the 3 techniques that I talked about. So the protege effect, practice problems, and blurting. So we're going to start with the protege effect, and I'm just going to explain to you guys a couple of topics. So basically, let me just explain to you guys what sequences and series are. So sequences and series. So basically a sequence is just a for lack of a better word, series of numbers, even though it's not a series. So it's just a list of numbers, essentially. So a sequence could be, it's kind of just like an infinite pattern of sequential numbers. So one sequence could be 2, 4, 6, 8, right? We're adding 2, basically, each time. And it could go on to 10, and then 12, and then 14, and then 16, and so on. So that's a sequence. So a series is if you add them. So a partial sum of a series is like the third partial sum of the sequence 2, 4, 6, 8, and so on would be the third, after the third term, so it would be 2 plus 4 plus 6, which would be 12. There's lots of different equations to use to find a certain term number. So if you know the pattern, then you can create a certain equation for it. So if I have a sequence that's 2, 4, 6, 8, to do that, I would think, okay, so let's just add 2 each time. So t sub n, which would just be any term number in that sequence. In fact, let me just write this down. It would be t sub n equals t sub 1, and t sub 1 is just 2, basically, but we use t sub 1. T sub 1 plus 2, but it's not just plus 2, it's plus 2 times n minus 1, I think it would be. So there's certain times you could probably think about, like, how did you figure that out? But once you do a bunch of equations, there's kind of 2 forms that they can be in. A sequence or series can be either arithmetic or geometric. arithmetic or geometric. For some reason it's pronounced a different way. So an arithmetic sequence is just a adding sequence kind of. So 2, 4, 6, 8, you're adding 2 each time. So there's a common difference. If you subtract one from the other, then it's arithmetic. And then a geometric sequence is when you're multiplying. So 2, 4, 8, 16, 32 would be a geometric sequence because you're multiplying by 2. And in there's a common ratio. So when you divide a previous term by a term, when you divide a term by its previous term, then you get a common ratio for each term. So there's a couple different forms of equations depending on whether it's arithmetic or geometric. So because 2, 4, 6, 8 is arithmetic, we have t sub 1 plus 2 each time. But since it's each time, if we're looking for like the third term, then we'd have to do 3 minus 1. So we do because we're multiplying, we're adding 2 3 times basically. But we do n minus 1 because this weird thing with like t sub 1 is technically adding 1, but then like it's kind of like the starting from 0 thing when you're like, when you're counting. Maybe it isn't like that. I don't know, you do like n minus 1 because we already have the first term. So if the first term was not part of the sequence, because sometimes that happens, then I'm pretty sure we would only do n. See, this is something that I need to review. So this is something I need to figure out because it's hard for me to explain this to you guys, so I need to figure out how that actually works. So basically, that's what a sequence of series is. And I want to explain for a series, if you want to find a partial sum. Whoa, the light. Yeah, look at this beautiful human being. Anyways, there's a partial sum, which has this sigma notation. I don't know if you guys can see that. Where basically on the top, we have, it's basically like this. There's lots of different letters that are used, and it kind of gets confusing. This one. So S sub n, I don't know if you guys can see that. For some reason it's not focusing. S sub n equals this sigma notation. So n, or actually no, let's start with k. So t sub k is going to be this equation. K is sort of like the term number. So basically to find the partial sum, we're going to start at k equals 1. We're going to do it to this. We're going to write that down, and we're going to hit plus. So let's just use this equation. So we're going to start at k sub 1. So k sub 1 would be 2 plus 2 times k minus 1. So this would be 0, so this would be 0, so this would just be 2. So we have 2 plus, and then we're going to do k sub 2 all the way up to n, basically. So we're going to do k sub 2, do it with the equation, add that there, plus. And then we do k sub 3, do the equation, add that there, plus. And we're going to do that until we get to the nth term for k, basically. So it's if n was 3, then we do k equals 1, boom, k equals 2, boom, k equals 3, boom, and then that would finish, and that would be our third partial sum. Because this n and this n here are the same. So if we're looking for s sub 3 equals 3, all of this, then it would be what I just said. I hope that makes sense. I think I explained it well. So now let's do a problem, practice problem. Let's do problem 7. So I'm just going to write down the problem. We have 6. And then sigma notation, k equals 1. And then k squared plus 1. Okay, so you guys can't really see my paper, but that's okay. So basically this is this equation. So this is the equation that we have to plug k into. So, and then 6 is the number we have to go up to. So we're going to start at 1. So 1 squared is 1 times 1, which is 1. And 1 plus 1 is 2. And then plus. So this is the sixth partial sum. So we're going up to 6. So 2 squared is 4 plus 1 is 5. 3 squared is 9 plus 1 is 10. 4 squared is 16 plus 1 is 17. 5 squared is 25, so 26. And then finally 6 squared is 36. Plus 1 is 37. So then once we have all these numbers, then we can add them up and then use my calculator because I don't want to use my brain right now. 2 plus 5 plus 10 plus 17 plus 26 plus 37 equals 97. And that is my answer. Okay, so let's check. Let's check it. Make sure I got that right. If not, make sure I know why I got it wrong. This is 11.4. 97. Let's go. Okay, so now to demonstrate the last active recall skill that I like doing, I'm going to do some blurting. So I'm basically just going to write a mind map about sequences and series. So this is going to be a hard thing to write a mind map about, but if we have sequences here and series here, then we could say 2, 4, 6, 8, dot, 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 2, 4, 8, 16, dot, dot, dot. So those are sort of the examples. And then for both of them, there's arithmetic and geometric, which has R and then D, R and D. And then with series, you could have a partial sum. So S sub n equals n, k equals 1, and then d sub k. And then what else is there? I mean, I don't need to go super in depth. But, yeah, that's basically that's the basics of it. But then there's all these equations, but I don't think I need to write those down. Oh yeah, there's convergent series. So if R is less than 1, then it's convergent. So basically it's an asymptote. So yeah, I didn't want to go super in depth. I just do a couple things just to get the basics down of like sequences and series and what they are. But yeah, that is me demonstrating the protege effect, doing a practice problem, and blurting. As you can see, when I was blurting, I kind of just wrote everything I knew. I looked back and forth just to look for keywords that I can explain with my mind map just from the textbook. I didn't like read it all though. I just saw convergent geometric series and I was like, oh yeah, and I wrote that there. So yeah, those are the 3 techniques, and yeah, let's move on. So now that we've gone over what spaced repetition and active recall are and how to implement them, I want to talk about the danger of using active recall and why I don't recommend flashcards. I think spaced repetition and active recall can become a sort of overkill technique. A lot of people only rely on creating active recall questions and just doing them over and over again over a spaced period of time. I don't think this is efficient because there are a lot of other study techniques out there, even ones that are more effective. Don't get me wrong, these 2 techniques can boost anyone's knowledge level, especially if they're coming from a very non-effective study system, but it is possible to sort of go overkill on active recall when you could be much more efficient with other techniques. I'm going to continue making videos about these other study techniques, so make sure you subscribe for when those come out. Now, the reason why I actually don't recommend lots of flashcards, which is a very popular system for studying, is because they're very disconnected from each other and they don't provoke you to actually understand the material. I find that it's much better to just genuinely understand what the thing is without memorizing a word-for-word definition. I've definitely experienced an illusion of knowing because I memorized a definition but still had no idea what it meant. So I recommend only using flashcards for disconnected things that need to be memorized word for word or specifically, such as dates in history or something like math constants. So that is spaced repetition and active recall, two beginner study techniques that are very effective. To recap, spaced repetition is studying over time instead of in one chunk of time, and active recall is just testing yourself. I hope that once you guys implement these techniques in your study system, it'll improve your overall knowledge of that topic as well as grades. As I mentioned before, I'm going to continue making videos about learning and studying, so stay tuned for that. Yeah, thanks for watching. I hope you guys liked this video. I worked pretty hard on it, and stay tuned for more and better study technique and just overall self-improvement content. So, see you later. Bye. Okay, cool.